Hello, this is Nikki Jackson, one of the adjunct instructors for Concord Career College. And as you can see right here, we have a few examples pertaining to radicals. So another way of saying a radical is the square root. However, with the square root, it's going to be indicated by not having a number right there. It's assumed that it's going to be a 2. And if you can see right here, still have the radical sign, but this is not a square root. This is called a cube root because you have your 3. So notice how you have the radicals, and you also have the answers given to you. So let's take a moment to actually figure out how they got that. Also, make sure that you're actually pausing and rewinding the video in case you have some additional questions as well. So in regards to number 1, let's look at it. Alright. So I'm going to have to do a lot of zooming in and zooming out, so hopefully you guys can see it. Alright, okay. I'm doing a lot of alrights. So notice how you have a negative square root of 36 over 49. So what I did was simplified it by breaking down the radicals. So I have 1 on the top, which is your numerator, 1 on the bottom is your denominator. The radical is not an issue. It's this negative sign. The negative sign always goes with the top part, which is your numerator. So we got negative square root of 36, then positive square root of 49. You know that the square root of 36 is 6. Bring over the negative sign, and then the square root of 49 is 7. So you either can write it as, excuse me, negative 6 over 7, or you can write a negative, then write the fraction itself. Now you probably can't see what it is over here because it's faded. My apologies, but I did previously state it. Only the numerator is negative, but you can write it either the negative 6 over 7 or then a negative and then 6 over 7. Your next one is also pertaining to a radical. So for your number 2 example, you have negative 6 times the cube root of 40. So I leave the negative 6 alone, but under the radical sign, I'm going to think about what can give me 40. So the first thing that popped in my mind was 8 and 5. So I want to break down my 8. So 8 gives you 4 and 2. Bring down your 5. I can break this down even more. Notice I'm saying breaking down is the same thing as factoring. Factor out to 4. So that's 2 and 2. Bring down this 2. Bring down that 5. Notice how I crossed out the 2's because you have a set of 3. Remember, this is a cube root, so we can factor out anything that we have a set of 3. So the 2's are gone. So now I'm going to bring that 2 out right here. So now I got negative 6 times 2, cube root of 5. I can't break 5 down because it's a prime number. So to simplify, you have negative 6 times 2, which gives you negative 12. Your final answer is negative 12 times the cube root of 5. We have even more radicals. So, music. Okay. Given to you, you have 2/5 times the square root of 32xy cubed. Well, I know it's a square root because it's going to automatically assume that you're looking for a set of 2 when there's no number indicated right here. So one of the things that I did, I broke down the 32, so that's 8 and 4. I brought down my x, and then I wrote the 3 y's out because that's to the cube root. Also bring down your 2/5. I'm still factoring. So I broke down the 8 and brought down the 4. 8 is 4 and 2. Still brought all my variables down. Now remember, we're looking for pairs because this is a square root. You're going to automatically assume that it is a 2. So notice how I crossed out the 4 because I have a set of 2. Then I crossed out these 2 y's because I have a set of 2. So that brought the 4 over, and I brought the y over, brought the 2/5 down. Notice under the radical sign that I'm left with a 2, an x, and 1 y. Now we're going to simplify it even further. trying to eliminate the fraction if possible. And you can't because 5 is a prime number. So now we got 4 times 2, it gives you 8. Bring over the 5, bring over the y, and everything that was left under radical, we brought it down. So your final answer is 8/5 y times the square root of 2xy. Here goes a few more items. So I'm going to have to do quite a bit of zooming in and out on this one. Okay. So you have the square root of 5x divided by the square root of 48y5. Notice how the first step, what I did, was I brought it over, trying to see if I can have anything that I can multiply by. And what I'm looking for is a perfect square. Perfect square. So I had to break the 48 down all the way because I know the 45 is prime. I'm sorry, the 5 is prime. So if you can see right here, I was trying to find something that could give me 48 and still have a perfect square in it. So 1 times 48 gave me 48. 2 times 24, none of these are perfect squares, but the 16 is a perfect square. Here's what I mean by a perfect square. What gives you 16? 4. So that's where the perfect square comes in. So now we're going to rationalize this. So we're going to multiply by a square root that will give a perfect square in the denominator. So that was the 3y, or the square root of 3y. Hopefully if I zoom in, you can see it a little better. So multiply everything by the square root of 3y. So 5 times 3 gives you 15. Bring over your x, bring over your y. So that's square root of 15xy. Now we're going to multiply 48 times 3. That gives you 144. 5 plus 1 gives you 6. So that's where the 6 comes from. But since that 5 is a prime number, we can't factor out this 15 any further. So you're left with the square root of 15xy. But we do know that the square root of 144 is 12. Because we're looking for pairs, you can factor out the 6 by 2. So 6 divided by 2 gives you 3. So your final answer right here would be the square root of 15xy divided by 12y cubed. You have 2 examples here. So for your first one, you're trying to combine like terms using addition. So you have negative square root of 16x plus 4 square root of 25x plus 7 square root of 36x. Notice how all of them have x under the radical, and they're also all perfect squares. So square root of 16, is 4. So that would be negative 2 times 4. Bring down the square root, bring down your x. Negative 2 times 4 is negative 8. Square root of 25 is 5. Factor out the 5. So 4 times 5 is 20. Bring down the square root of x. 36. Square root of 36 is 6. 7 times 6 is 42. Bring down your radical. Bring down your x. So now you can combine all your like terms. So you have negative 8 plus 20, which gives you positive 12. Positive 12 plus 42 gives you 54. Your final answer is 54 square root of x. Your next example is combining subtraction with the distributive property. So you got a lot of square roots going on. So we have 3 times the square root of 2 times 5 square root of 5 minus square root of 7. So notice right here, what I did was the distributive property. So 3 times 5, and then I got my radicals under them. So I left that under there. And then I did the next one. I did 3 square root of 2 times 7. So with the outside of the radicals, you got 3 times 5, which gives you 15. On the inside of the radicals, you got square root of 10. Using distributive property again, You have 3 on the outside, but on the inside you got 2 times 7, which gives you 14. You can't simplify this any further, so your final answer is 15 times the square root of 10 minus 3 times the square root of 14. Now we're actually using the distributive property for your 7th example. So you have square root of 2 plus 5, and the next binomial is square root of 2 minus 7. So I'm using 4. So the first terms of the parentheses, outside term of the parentheses, inside term of the parentheses, and the last terms. You may recall this from a previous module. So we got square root of 2 times square root of 2 plus square root of 2 times negative 7 plus 5 times square root of 2 plus 5 times negative 7. So whatever's on the radical, so we got 2 times 2 is 4. Then these are out, 7 is outside, so you got negative 7 square root of 2. The 5 is also on the outside. And we know that 5 times 7 gives you 35. It was going to be a negative 35. The square root of 4 is 2. Then we brought these two right here. We're going to combine those because negative 7 plus 5 gives you negative 2. Bring down your negative 35. Now we can combine like terms with the 2 minus 35. So that gives you negative 33 minus square root of 2. 2 times square root of 2. So make sure that you repeat this because I went kind of fast on that one. Notice how you combine like terms again and you simplified it with your square root. Now in regards to radicals and rational expressions, this becomes a little bit more complicated. So whenever you have a radical under the fraction, aka the denominator, you're going to have to rationalize it. And the rationalization is pretty much like the opposite of it. So what we're going to do right here is multiply everything by square root of x minus 12xy. Now the reason why we're doing that is because it's addition has the opposite of subtraction. Plus we don't want these radicals everywhere. We don't want a radical in the denominator, hence that's why we got to rationalize. So right here, notice how I'm multiplying everything by the opposite of this. So for your numerator, you're going to use square root of x times square root of x. Bring over your minus sign, square root of x. Bring over your negative 12. Notice how the square root of x now is under the radical with y. Your denominator, this is going to take a moment, so pay close attention. Using for a method, square root of x times square root of x. Square root of x times negative 12 square root of y, which is right here. Then we got 12 times the square root of x and square root of y. Then we're going to have a minus. 12 times 12 gives you 144. Both of your y's are under the radicals. We're going to simplify now. So the radicals cancel out because you have 2 of them, so that brings down the x. Bring down your minus sign. This stays the same. Again, the radicals cancel each other out, so bring down the x. These two terms cancel each other out completely because one is negative, the other one is positive. Simplifying this, bring down your negative 144, but your radicals cancel out because you have 2 of them. Bring down your y. So your final answer is x minus 12 square root of xy divided by x minus 144y. Your next one is very similar to an algebraic expression. So you have 3 square root of n minus 2 equals 0. So in order to solve for n, I added 2 to both sides. So now I'm left with 3 square root of n equals 2. Divide everything by 3 now because we're going to get the n completely by itself. So now you have 2/3. Yes, you can have fractions. Now here's the trick. You heard me previously say that square roots cancel each other out when you have 2 of them. So they cancel again. So that's where the n comes from right here. But if I square it on one side, I also have to square it on the next side. So 2 times 2 is 4. 3 times 3 is 9. Your final answer is n equals 4/9. For additional assistance with this, make sure you watch the other lecture videos that are also posted in Canvas. Very similar to the example that we just did, we have square root of y plus 1 equals 5. We want to solve for y, so we're going to square everything to get rid of that radical. So once we square it, we have 3y plus 1 on the left-hand side, and we have 25 on the right-hand side. Subtract 1 from both sides right here. That's where you get to 24. Then we're going to divide by 3 on both sides here. Now you have y equals 8. Here's another where you have to square on both sides. So notice how you did 5x plus 4 squared and then 6x plus 1 squared. That cancels the radicals. Now you are left with 5x plus 4 equals 6x plus 1. Well, I'm going to subtract 1 from both sides to combine my like terms. So that's what I did right here. So now we're left with 5x plus 3 equals 6. Subtract 5x from both sides because you're still trying to combine like terms. So you're going to bring down your 3. 6 minus 5 is 1. There's no need to write the 1x. So your final answer is x equals 3. Now what we've done so far, we have come up with answers for all of our problems. Your answers are also known as solutions. But for this particular one, let me try to zoom in. It's kind of difficult to see. Also, my apologies for my voice. My sinuses are draining. That's what happens when you sleep under a fan in the wintertime. Summertime too. Okay, so we're going to get the square root and eliminate it by squaring both sides of the equation. So now we got n squared minus 9n minus 18 equals n squared. Well, one of the things that we're going to do right here is combine your like terms because you got an n squared here and an n squared there. Well, if you do that, it's no longer a trinomial. So you can't do that because it's going to eliminate these. These is going to be 0, so you can just stop right there. The answer is going to be 0. So not all of them are going to be able to do that. Sometimes you can actually break them further down. Just be mindful of that. Here's an example of what I mean when you're going to break it further down. So this is your 13th example. So once again, we're going to square on both sides of the equation to get rid of the radical. So we got rid of the radical right here. But notice right here, we have now created a trinomial. So using the FOIL method, you're going to do x minus 3 times x minus 3. So let me write that out for you. So x times x gives you x squared, then 3x times x is 3x, and 3x times x is 3x, and 3 times 3 gives you 9. So that's where this comes from. We're going to combine our like terms by subtracting 44 from both sides. So now we're left with negative 4x equals x squared minus 6x minus 35. Still going to combine like terms because we want it to equal 0 now. We're going to add 4 to both sides. So here's the important part right here. So this is the ideal time for you to actually pause it to see how we combine our like terms. Now when you're trying to determine your answer, especially if it has a radical, you can't have a negative. So what we did right here with this trinomial, we factored it out. So what can give you 35? With 7 and 5. So I split my x's. So here goes one x. Here goes the other x. Here goes my 7. Here goes my 5. Well, look at your middle term now. Your middle term is negative. So that means that the negative sign is going to go with your larger factor. Your larger factor was 7. Hence, that 5 has to be positive. The reason being, look at your last term now. You may recall when we were factoring binomials and trinomials, they had to be unlike signs in order to get this to be negative. They had to be like signs in order for the last term to be positive. So now that we've seen that, how will we solve for x? Well, if we were to add 7 to both sides right here, we know that x would be a positive 7. Yeah, you can actually have a negative 8 too, but because of this particular problem, it cannot be negative. So you have to make sure that you know exactly what your answer is asking for. We have another one that we have to rationalize in a sort of funny way. Instead of the square root now, we have the cube root. So we have the cube root of x minus 2 equals 2. To get rid of the radical, we have to cube everything. So once we cube everything on both sides, we're left with x minus 6. 2 cubed is not 6. This is 2 times 2 times 2. So that's where we're getting the 8 from. Combine your like terms right here by adding 6 to both sides. So your final answer is x equals 14. Here's another example of a cubed root. So once again, we have to cube both sides. So eliminate, which I did not write down, so I'm going to write it for you now. So eliminate your cube roots by cubing both sides. And what I mean by both sides is cubing both sides of the equation. So in other words, they cancel each other out. Now we're left with 2x minus 9 equals 4 minus 6x. Alright, we can either subtract the 4 or the 9. I want to keep my numbers positive if possible. So I add 9 to both sides. So now I'm left with 2x equals 13 minus 6x. We're still going to have to combine like terms in regards to our variable x. So add 6 to both sides. So now we have 8x equals 13. Isolate the variable of x by dividing both sides by 8. And you have 13 over 8. So once again, your answer can be fractions. Be careful, ladies, gents, individuals, when you put this in the computer. So now I'm looking for the next example. So my apologies if you hear all the paper just going back and forth, back and forth, back and forth. Where is this problem? We're in this one. Alright, well I can't seem to find number 16, so yeah, I get to work it out live. Woo-hoo. So here's your 16th example. You have the square root of n minus 3 plus, I did this one and I don't know what I did with it. I did this problem already. Wait a minute. Yes, ladies and gents, individuals, I am talking to myself. I talk to myself because there is no one to talk to. People ask me what I do, what I do. And now I remember why I did not do that one. Because of the time. Because I'm looking at my video time now. So, my apologies in advance. You're going to have to figure this out on your own. But be mindful, you will be squaring everything so you can get rid of the radical. And now we're going to go to number 17, which is dealing with exponents and how you write them down. So that's totally my fault, y'all. And I remember why I didn't do it. Okay, so for this one, you have a negative exponent. Now you may recall from a previous example, depending on what your exponent was, it was the reciprocal. Well, in this case, notice that you have a negative. So if I did the reciprocal of that, that's going to be the cube root. So now you have your denominator. So if I was to rewrite this, that would be 8 to the 1/3 power, which you can rewrite like this. Because you know you had to flip it because it was negative. Notice how your exponent is no longer negative. We know that the cube root of 8 is 2, because if I break this down, we have 2 times 2 times 2. Notice how you have 3 of them, it's the cube root. Here goes another one regarding exponents. So notice how your denominator and numerator just determine what's going to be on the inside and what's going to be on the outside of it. So this is kind of tricky. This one right here was already given to you. This was your example. This one right here is which one you're trying to solve. So they were giving you like a format for it. So only one of them you're trying to solve. So again, notice how your denominator is what's on the bottom. Your numerator is what's on the top. In other words, your numerator goes inside the radical. Your denominator goes outside the radical. So this one right here was just an example for you to actually use to work this one. So your final answer is the 5th root of x to the 6th power. We have another one that requires us to rewrite using positive exponents. So this one, we know we're going to have to the 1/4 power, because notice how the 4 is on the outside. We also know we're going to have to distribute a negative power, so the final answer is negative x plus y to the 1/4 power. So notice what's on the inside of the radical is on the inside of your parentheses. And again, your powers, whatever is on the outside, that's going to go on the bottom. Same thing for this one. So I'm leaving both of them up where partially up. Notice how both of them have a denominator of 9, hence the 9th root. There's a 1 right here, so you only have the 1y, and there's a 4 right here, hence you have the 4x, or the x to the 4th power. So that's 1 apart. Now we're getting into imaginary numbers. And I know they're imaginary numbers because I see the I. So you may recall when we were in class the first day, we went over real numbers and imaginary numbers, where imaginary numbers are indicated by I. And another way of remembering that, we know that I is just going to be all by itself. So I got negative 1, negative I, and positive 1, which you cannot see because I wrote out a bit too far to the side. Here we go. Okay. Yay. So my apologies for that. So anytime we have I squared, that's automatically negative 1. So we're going to use combining like terms. So we got 5 minus 6 plus 3i minus 7i. So this negative is going to make that positive a negative right here. Once we combine like terms, we know 5 minus 6 is negative 1. And then negative 3i minus 4i gives you negative, I'm saying 4i, 7. But yeah, that's your final answer. I'm getting tongue-tied, y'all. So we got negative 1 minus 4i once you combine your like terms. I'm looking for my other examples. Where did they disappear to? Okay, here we go. So now we're using multiplication. So before I started to multiply, I wanted to simplify it a little bit. So right here, I broke down my 22, and then right here, I broke down my 32. What we're trying to do is get an I. We're trying to find out that negative I. So right here, we know the factors of 22 are 2 and 11. But this 32 we can break down. So we got 8 times 4 is 32. So I broke down my 8. So that's the 8 is 2 and 4. Bring down this 4. So now I can multiply everything and see if I can factor it out. So I have a set of 2's. Now I cannot have a negative on the inside of the radical, so that's where that negative I comes from. So now I got the 2's, bring down the 11, bring down the 4. I still have a pair because we're dealing with the square root, so I factor out the 2, which is right here, factor out the 4, which is right here. So that's why I brought it out. So I have 2 times 4 times negative I times square root of 11. 2 times 4 is 8. 8 times negative I is negative 8i. Left your radical alone, so your final answer is negative 8i square root of 11. So going back up here, I cannot have a negative in the radical side. Hence, that's why I factored out that negative I. Using FOIL method, aka distributive property, for this one, we're going to multiply everything that we see. Or whatever's on the outside by each term that's on the inside. So now I have 5 times 8, and then the 5 times the minus I. I just brought the minus sign over here. Minus 4i times 8, and then minus 4i times, excuse me, negative I. So 5 times 8 is 40. Bring down your 5, minus 5i. Bring down your minus 32i. Then we have 4 times I squared. Now here's the reason why you have a plus sign. 2 negatives give you a plus, and you see 2 i's. But remember, I squared all by itself equals negative 1. So now I have to simplify and combine my like terms. So now I have 40 minus 37i minus 4. Remember, the I squared is the same thing as negative 1. So 4 times negative 1 gives you minus 4. These two are constants. So they don't have a variable, so 40 minus 4 is 36. And bring down your minus 37i. Final answer is 36 minus 37i. Here goes another one that might be a little more complicated. There's no little part to it. It is. Because you're dealing with rationalizing an expression. So bear with me, people. Alright. So we got negative 5 plus 8i over negative 1 plus I. We can't have the negatives right here. So we're going to, very similar to what we did with the radicals earlier. So we're going to rationalize. We're going to mean to multiply everything by the opposite of your denominator. So the opposite of addition is subtraction. So that's why we're multiplying everything. So here we go, step by step. So negative 5 times negative 1, here it is right here. Negative 5 times negative I, here it is right here. 8 times negative 1, right here. And then 8i times negative I, here. Denominator, excuse me. Negative I times negative I, here. Negative 1 times negative 1 is here. Negative 1 times negative I is here. I times negative 1 is here. And then the I squareds. We're going to simplify everything. So we got 5 plus 5i minus 8 plus negative 1. Because remember, I squared, which is right here, is the same thing as negative 1. For your denominator, we have 1 minus 1i minus 1i plus 1. So we can still simplify. So these middle terms right here, they can be combined. So we got 5 minus 3i minus 1. Same thing for these middle terms. That's going to be negative 2i. 1 plus 1 gives you 2, so that's why it's simplified so far. 8 minus, I forgot my negative right there. So yeah, it's supposed to be a negative 5, but I did not write. There we go. Or did I do something wrong? I think I still did something wrong. Because 2 negatives do give you a positive. I did a sign change somewhere that I should not have done a sign change. And that's throwing me off right here. Throwing me off right there. Throwing me off right there. That's why. I was doing it right. That is a positive. Right here. Excuse me. This is where I got off right here. It's supposed to be a negative right there. So ladies and gents, don't make the same mistake that I did. There we go. Alright. So my apologies for that. Do not make the same mistakes. Charge it to my mind, not to my heart. So now we have 5 plus 8 gives you negative 13, because both of them are negatives. Factor out down here at the bottom. So once we rewrite this, that's going to be 13 over 2 minus 2i. I'm sorry, minus 3 over 2i. So what you did is just split them. So you got this part split, and then the I split right there. And again, that's supposed to be a positive. So my fault. And then you got your last one. So we have 8 plus 4i squared. So we're going to factor each other out. Or actually, we're not going to factor. We're going to use the FOIL method. So 8 times 8 is 64. 8 times 4i is 32i. 4 times 8 is 32i. 4 times 4 is 16. Then we have I squared. Combine your middle terms. So now you have 64 plus 64i plus 16 times negative 1. Because remember, I squared is negative 1. Combining this, so we got 64 minus 61 plus 64i. So 64 minus 16 is 48. Bring down your 64i. Final answer is 48 plus 64i. Woohoo! So ladies, gents, individuals, my apologies for being all over the place. But hopefully you'll be able to determine what the answers are and not make the same mistakes like I did. So thank you for watching.